All right, kiddos, so for part of this week, one of the things that we're going to be talking about is obviously parts of the whole. Now, well, that's spelled incorrectly. It should be toughest with a G in there. I guess I go back and fix that. One of the toughest parts of matter is parts of the whole. And I kind of hate you weren't able to see the first class, because I still, even after doing multiple quote-unquote experiments in here, they still, every single time that I take the Twizzler and I chop it into little pieces, I take the Play-Doh and I break it into little pieces, I take Legos and break them into little bitty pieces, I take the goldfish and smash them into little bitty bits, every single time I have people in like 3 camps in my room. The first camp is they go, oh, those are smaller, certainly it has to weigh less. I have people that look at me and say, well, no, Mr. Bullens, you had 1 Twizzler. Now you have like 15 little pieces of Twizzler. It has to weigh more. And then I have very few of these, but thank goodness I have a lot more in this one. I have a lot of people that go, well, Mr. Bullens, like that Play-Doh ball that you had, I know that we broke that into like 1,000 little pieces, but you didn't add any Play-Doh, you didn't take any Play-Doh away, so certainly all those pieces have to equal what the whole Play-Doh ball did, and I'm very happy that the people in this class are getting that, because it means you're already past the misconception portion of this, which is super awesome. So again, just for the people that are at home, we're going to go over this again one more time in here with us, talk about it a little bit so they can hear, they won't be able to see what we're doing, but they can hear it at least, and get an idea, and then we're going to move on to some different types of notes as well today. I'll record that for them, post all that in my Google Slides. Kids, we're starting to hit this weird time of year again where if you've noticed in different classes, there's people out a lot, right? Luckily, this class is not many. My class got hammered, and I think Miss Weevil's got maybe 4 or 5 people out. The possibility of any of us at any time having to go home is there, right? So we need to go back and kind of think about, well, what do I do if I am out? Well, if you are out, you need to obviously log into mine, Miss Klein's, and Miss Weevil's Google Classroom. You know that I post everything under classwork for the most part. And then you find whatever week we're working on, which would have to be 12/6 through 12/10, which is us right now, right? You click on that. It tells you right here that I put everything in the Google Slides. And obviously I attach any extra stuff into here as well, right? Because, well, this is kind of important for us also. Please go into the Google Slides each day. Again, this morning, interrupted by like 30 minutes of a meeting with the counselor. Miss Alexander came in. So I may not post immediately my videos. I have to wait until I can get them recorded. But again, right in here to tell you everything that we're doing. I'm going to use this Advent calendar the entire month because that's just something fun to use as the Advent calendar. So you go to December 6th. What are we doing today in class? Continuing solid liquids gas, looking at parts of the whole, and begin the solid liquid gas project. And a little bit more than that. I'll go back and add some more stuff. And you just kind of go through each day. And as you've ever seen it, if you've ever done it, I will attach the videos for today right after this slide. So you should, like what I'm recording now, will show up right after this slide in just a little bit. Does that make sense? So if you happen to end up at home, you don't have to question what you should be doing in my room. They might do it completely different in Mrs. Klein's room and Mrs. Weevil's room. That's just the way things roll. Sorry about that. So let's go back to this parts of the whole that people seem to struggle with. And we started off with goldfish, right? And as this so slowly, my goodness gracious, I feel like we're using dial-up or something. This is awful internet speeds. If there's any parents watching this, they're going to laugh because it used to take this long for pictures to download when we first got the internet. It was like awfully slow. It was like just, you'd leave and come back an hour later and the picture's like halfway loaded. Well, we took a small cup of goldfish and we weighed it. And I don't remember exactly what our goldfish weighed in. Was it 34 grams? I think that sounds right. 34 grams. So that it was like a tiny little cup of goldfish. We weighed it 34 grams. I put it into a bag and smashed them to bits, right? It was like sand when I got finished with it. And I asked you the question, what weighs more, the full cup of goldfish or the tiny smashed up pieces? And I asked you why. And on the first trip around, we had a few different answers, and we definitely had some different answers. When we measured the cup of goldfish versus the cup of smashed goldfish, they weighed the same. Some people wanted to say, yeah, but the pieces are so much smaller. It doesn't even take up as much room in the cup, which it didn't, right? When I smashed them, it took up way less space, like 25% less space. And I understand why someone might think, well, that definitely weighs less now. But you got to think those goldfish pieces are bigger, and there's space in between those goldfish, right? When you're looking at goldfish, there's space in between them versus if you smash them, there's definitely not as much space in between them. I understand why someone might say it weighs more. You have more pieces of goldfish than you did before. I can understand that. But then when we did the first thing around, we started to talk about it, it started to make more sense. Did we add any goldfish to the cup? No. Did we take any goldfish away? No. All I did was smash them, which I think Miriam said that's a physical change, which is true. I didn't change the goldfish at all. It was still goldfish. If I'd eaten that, it would have still tasted like goldfish. All I did was change the size of the goldfish. I still kept all of the parts, right? All of the parts of the goldfish. And when I put all those parts together, they made the whole goldfish, and they weighed exactly the same. So again, the misconceptions on this are very easy to make, but I don't think we're going to dig into that too deeply because it seems like in this class, and I'll be interested in the last class to see how well they grasp it, or if we need to spend a little bit more time going over these different experiments. And we'll do some more the next day and some more the next day. But parts of the whole, I'm not going to stand up here and spend like hours on hours on hours of parts of the whole. I'm going to spend maybe 15 minutes a day before we jump into other things. Does that make sense? All right. Moving on. Maybe. I should have hit the air alarm. We had Play-Doh. We took the Play-Doh out. We smelled it. Smelled good for most of us. Some of us hate the smell of Play-Doh, and that's fine. I'll buy them some cologne. So we take the Play-Doh out, and we rolled it into a ball. When we rolled the Play-Doh into a ball, if you even looked on the container, it said 83 grams of Play-Doh, right? And when we took that Play-Doh in like one giant ball, we all sat at our desk for a few minutes and broke that into teeny tiny little pieces. Now, when I broke mine into pieces, I tried to fit it back into the original container, and it wouldn't fit. So I understand someone thinking, well, that's definitely going to weigh more. It won't even fit in the container. There's more pieces. I get that. I can understand the misconception. I can also understand somebody saying it's going to weigh less because you have smaller pieces. But what I really enjoy is those of us in here that are like, nah, you're not even going to trick me with that, Mr. Bullens. Like, you didn't add any Play-Doh. You didn't take any Play-Doh away. It's still the same amount of Play-Doh. Even though you broke into 1,000 little pieces, it's going to weigh the same. So again, it doesn't weigh more because there's more pieces. It doesn't weigh less because the pieces are tiny. We all in here understand that the parts are equal to the whole. Do you agree with that? The parts are equal to the whole. The Play-Doh and the tiny pieces weighed the same because we didn't add anything extra. We didn't take anything out. Even the Twizzler stick that I had, 11 grams of it. I cut it into tiny little pieces. Did I add any Twizzler? Did I take any Twizzler away? No, it was the exact same amount of Twizzler. And because we did it that way, I think in here we're starting to grasp parts of the whole. So we're going to start every class with tiny little experiments about parts of the whole. And then I'm going to start showing you what the questions look like on SchoolNet so that you can get an idea of what those are like. Because trust me, it's not all Play-Doh and Twizzlers and goldfish. But for stuff for us to understand, I think we'll use it that way. And I think that'll be a little bit better for us. All right, so I'm going to talk to you as a class. I'm going to talk to the people at home a little bit about this project. Now, I'm going to imagine most of the people at home probably didn't take home those pyramids that we cut out last week after our quiz. I'm going to assume they're probably sitting at home with nothing. If they happen to have the pyramid, they can follow along and create this physically. And for those of us that might be at home and you don't have it, then you can do it virtually, and you can use these Google Slides. Do you have to use the Google Slides if you are in my room right now? No, because you all have pieces of paper. Most of them are folded very nicely. Some of them, I think, took a trip like across country on the back of a wagon, like under the tire, the entire way back and forth across the country. Yeah, it's definitely folded. Again, here's our project about states of matter. We're going to work on this together in class like we do most of our projects. Your slides or your project need to have the following things, and I'll give you the rubric for this in just a few moments. You need to have the vocabulary word and the definition. So for us, we are going to start off with solid. Who can give me a good definition of solid? Rachel. Definite shape takes up a definite amount of space, which means it has a definite volume. And you'll notice I have that here. Not very well for them to see. There we go. Go ahead and get this down on your piece of paper. All right, so Anna, I don't think that jotting down the vocabulary word and the definition is very difficult, is it? Number one, you have your vocabulary sheet you can refer to because you should still have that. If you don't, you lost it. Guess what? It's attached in Google Classroom right here, right? So that shouldn't be a very difficult thing. If I'm looking at this, if you're working online, I need put a picture. Whoops. A picture or a GIF of that word. Now you'll notice I have an exemplar here for the people that are at home. Ice is a solid. Here's my picture of ice with a definite shape and a definite volume. So the next thing that you need on your sheet if you're working with me in class is a picture. Now I personally would have drawn a picture, but my pen doesn't work on my board today for some reason. It stopped working, which I need to figure out real soon because I write a lot of notes on here. I don't mind typing them. But you need to draw a picture. Now, some people in my last class, they drew things like pencils and desks and cars and dogs. None of that is wrong. I personally would also draw a picture of ice, and I'll tell you the reason why. You will see that more often, and it's also going to help me when I move into the next part of the project when I talk about how these things can change into different phases of matter. Now, I probably should add this in here. Right now, we're working on solids, right? What do the molecules of a solid look like? Yes, ma'am. They're very, very close together, aren't they? And we've drawn that. Again, I can't draw on the board for some reason right now, which is very weird. Let me pause. So again, we've all written solid somewhere on our pyramid, right? We've written the definition, has a definite shape, takes up a definite amount of space, has a definite volume. We drew a picture, a representation of that. I'm using water for all of mine because it makes more sense as I start to change phases. Ice is a solid because it takes up a definite amount of space and has a definite shape. And then now we're drawing what the molecules look like. Now, some of you might start running out of room on the front side of that sheet of paper. That makes sense to me. Guess where you can go if you run out on the front side of it? You can flip it to the back side where you have solids. If you are at home and you start running out of space on your slide, use another slide. Just continue to label it solid. So right now, everybody is working on their molecules. So again, we have the molecules of each state of matter. I better put and a picture. Otherwise, somebody will skip that. Now, for the states of matter, we need to describe how they can move to other states of matter. Again, using correct vocabulary, definitions, and pictures. Looking something similar to this. There are two things that ice can do, right? Ice can melt. Can ice freeze? No, you can't freeze ice. It's already frozen. All right. Can you condensate ice? No, because that's what liquids do. You can't boiling. You can't put ice to the boiling point, that's a liquid. Ice can do two things. It can sublimate